Hello everyone, I'm Arman Srivastava, a first year student here at IIT Roorkee, and today I will be explaining you a C++ program to find the roots of a quadratic equation. So let's start. It's presented by me, obviously, Arman Srivastava. Let's begin. So what is a quadratic equation? So before explaining quadratic equation, let me tell you which you might be aware of a linear equation. A linear equation is like of the form a x plus b equal to 0. Okay. Here, the value of x would be x is equal to minus b over a, provided a is not equal to 0. Okay, so we all are aware about this. So here, the power of x is 1. Okay, 1 or this power of x, highest power of x, is also known as degree of the equation. Okay, so here the degree of equation is 1. Okay, so we all know how to solve this x is equal to minus b by a, but let's increase this degree of power. Okay, if the highest power of x in a quadratic equation in an equation, okay, is 2. So then that equation is known as the quadratic equation, and it is of the form ax square plus bx plus c. Okay, here a is called the leading coefficient. Okay, b is the coefficient of x and c is the constant term. Okay, so for this equation there would be two values of x which satisfies the above equation. Okay, so no matter what the values of a, b, c are, there would always be two values of x which would satisfy the above equation. Okay, here ABC are coefficients of the quadratic equation. We all know that. So now let's define a quantity D. This D is a very important quantity in determining the nature of the roots. Okay, so there are two types of numbers, complex numbers and real numbers. Okay, so complex number, you might be aware of real numbers. They are basically those numbers without a complex part. They are like 1, 2.5. These all are real numbers. Okay, and but complex numbers are like of the form a plus IB. This I means the imaginary part. Its value, if you are not aware, is equal to square root of negative 1. Okay. This I is equal to square root of negative 1. These are of the form A plus IB. A is actually, A can be anything like, suppose A is 1 plus iota. Let's say B is also 1. So the complex number would be 1 plus I. Okay. So the complex number of the are of the form this. So D is basically B square minus 4AC. B is the coefficient of X, A is the leading coefficient, that is the coefficient of X square, and C is the constant term. Okay. So this D is very important in determining the nature of the roots. If the roots would be real or complex. Okay. So we would see how this determines the nature further. Okay. So the nature of roots. So as I told you, this D is very important. So let's see how it is important. So if d is greater than 0, that means if the value of discriminant b square minus 4ac is positive, that means the roots of this equation, the previous equation, this one, ax square plus bx plus c, that would be real and distinct. Okay. If d is equal to 0, then the roots are real, but they are equal. Like the roots can be like 1 comma 1 or 2 comma 2. But in the first case, the roots will be distinct, like 1 comma 2, 1 comma 3, 2 comma 5, 0.5 comma 1, or anything like that. Okay. And in the third case, if d is less than 0, the roots are imaginary. Okay. Like as I told you, imaginary means complex numbers. So they would be of the form a plus ib. And note that the roots would always be distinct here. That's just an extra point. The roots, if they are imaginary, they would always be distinct. Okay. Let's move ahead. The formula for determining the roots, x is given by minus b plus or minus root over b square minus 4ac over whole over 2a. Okay, this b square minus 4ac, we know that this is known as the discriminant, as I told you here. This d is b square minus 4ac. So this minus b plus minus square root of d over 2a. So as you can see from here, if d is negative, the square root term would be negative and the roots would be imaginary. If d is positive or equal to 0, then roots are real. Okay. So let me explain you the idea of the code which we would be writing. Okay. So idea is like we would first ask the user to input the coefficients of the quadratic equation because these are very important in determining the roots. Okay. So we would be asking the user to input the coefficients of the quadratic equation, and thus the equation would be formed. Okay. It would be like x square plus x plus c for real roots. So there's a problem actually. For real roots, actually the code would work perfectly fine because the roots are real. But for imaginary roots, C++ cannot by itself give the term iota. It is called iota. Is equal to root minus 1, which I told you. Here it is equal to root minus 1. So the C++ is in itself is not able to write the term iota or the imaginary roots. It is not able to write it completely. So we would be introducing it separately. Like we would be printing an extra I, okay, so that the roots are correct. Okay. I would be explaining this, so don't worry. Let's say the equation is x squared plus x plus 1 equal to 0. So here the a equal to 1, a is equal to 1, b is equal to 1, c is also 1. Okay, so the roots would be minus b, that is minus 1, plus or minus square root of b square, that is 1, minus 4ac. So minus 4 over 2a, so 2. So the roots are minus 1 plus minus square root of negative 3 over 2. So as the complex part is, sorry, the term inside the square root is negative, so the roots are complex, okay? So see, the C++ cannot display this correctly. So what we do is minus plus. The real part is displayed as it is. The complex part, we do some modification. We display an I, this letter extra, and we change the term inside this square root as minus d. So this minus 3 would become 3. Okay. Like there is an extra minus sign included here. You can say this. An extra minus sign is included. So this would be 3 over 2. Okay. So now the roots are correct. And this is what we did in the code. So the code is like this. Hash include stream to include the libraries, necessary libraries. CMath, this is also a very important library. I would be explaining you what is the use of this. Then using namespace std, standard libraries, int main, double A. So we are just declaring variables A, B, C, and then we ask the user to enter the coefficients of the quadratic equation. C out A is equal to, and then we ask the user to input A, then we ask the user to input B, then C. Okay, and thus the quadratic equation would be formed: A x square plus bx plus c. Okay, so double D, this POW. Let me explain you what is POW. POW is basically a function in the CMath library, which is like this: x comma y. It means that POW x comma y is x raised to the power of y. Okay, like POW 1 2 comma 2 is equal to 2 square, that is 4. Okay, so here POW means this. Okay, power. So double D is equal to power of power b square. This b comma 2 means b square minus 4ac. So if d is greater than or equal to 0, as I explained you, there's no problem in the code and it would work perfectly fine. So minus b plus or minus power of b square minus 4ac, and this comma point 0.5 is actually the square root. This expression would mean like square root of b square minus 4ac. Okay, and minus b, you know the formula. Okay, so I have written that only. And then for the first root, if we cannot write plus minus simultaneously, so I have written the first root as plus and the second root as minus b minus. Okay, if you remember, there is also a plus minus sign here. Okay, so I have written these two roots separately. And if d is less than 0, again I have written those two roots separately. And here, let me tell you, this plus I is something which I have added extra to include the complex part also. And here also I have written minus d so that the square root term would be positive, and this extra I would mean that the roots are complex. Okay, and the other root is like this: minus I, minus sign is included. And just this would solve the quadratic equation. So let me take you through a sample output. Okay, so le- we ask the user to enter the coefficients. Let's say user input a equal to 1, b equal to 1, c equal to 1. Okay, so the roots would be, so sorry, the quadratic equation is like 1x square plus 1x plus 1, and the roots are minus 0 0.5 plus I 0.8666025. Okay, minus 0.5 minus iota 0.866025. So it works perfectly fine for complex numbers also. Okay, so this was the presentation. I hope you liked it and you got to know something new about how to find out the roots of a quadratic equation using C++. Okay, so hope you liked it. Thank you very much.